Okay, if I'm looking for g of y1, what am I going to do? If I'm looking for g of y1, right, I'm going to integrate this guy with respect to the variable I'm not interested in. Yeah, you want to ask a question?
Did you have the e to the negative y2? Where did that?
Oh, yeah, you're right. This one here. Sorry, that my bad. So that one is, that means we're following it. Okay, now I want to integrate. If I want to integrate this guy with respect to y2, I have to use the range of y2. Now, what is y2? Okay, x1, the range of x1 in gamma is 0 to infinity. S2 is also 0 to infinity. Automatically, y2 is also going to be 0 to infinity because you are adding them, right? Now, this is going to be 0 to infinity. Okay, now, my time. Okay, time flies. Now, so g of y1 equal, now if I want to integrate this guy with respect to y2, then anything other than y2 is going to be a constant. So this is going to be a constant. I'm going to write it out. Y1 alpha 1 minus 1, 1 minus y1 alpha 2 minus 1 divided by gamma alpha 1, gamma alpha 2. Then I'm going to have 0 to infinity y2 raised to the power alpha 1 plus alpha 2 minus 1, the y2. Oh, can somebody remind me of something? If I want to, it's a gamma function, thank you for that. So this is gamma what? Okay, recall from gamma function, okay, where you have the gamma alpha is 0 to infinity, y raised to the power this raised to the power that, the y. If I can write this as gamma alpha, what gamma is this guy?
Alpha 1 plus alpha 2.
Exactly. Send me a message for extra credit. This is gamma alpha 1 plus alpha 2. Now, finally, g of y1 is this. 1 minus y1 raised to the power this. Okay. Gamma alpha 1 plus alpha 2 divided by gamma alpha 1, gamma alpha 2. And you know that if I want to rewrite this guy here, y1 this 1 minus this divided by gamma alpha 1, gamma alpha 2. So this is the same as this is a beta distribution that we derived before, that we used before. So which means beta distribution actually come from gamma distribution and using what I call a function of random variable. Okay, let me tell you, there are so many distributions that can be derived. I'm going to write them out, the two major distributions out. Another one, has anybody heard about T distribution? T, okay. We use T distribution. It's a probability distribution that we normally assume when we are conducting a t-test. Has everybody heard about t-test in statistics? Okay. Now, let me tell you this. Let me say further proofs. Okay. Number one. Okay. Do you know that if I have take a look at this, t equal z divided by this, okay, if Z follow normal, okay, and W follow a chi-square with R degree of freedom, okay, and and giving that this, okay, derive the PDF of T, okay. This is number one, okay. The PDF of T that we want to derive, okay. Let me see. Okay, I think I'm going to write it somewhere. Now, another one, important distribution in statistics that was derived. As anybody has about F distribution, F, we use that in F test. Without F distribution, there's no F test. Okay, now number two, okay, if let me see, I take F equal to U over R1 divided by V over R2. Okay, so if you follow a chi-square with R degree of freedom and V follow a chi-squared with R2 degree of freedom, and they are independent, okay, so derive G of F. Okay, now I'm going to show you. You want to derive the distribution for T and the distribution for F. Okay, I'm quickly going to write where we're going. What what we want to derive. Now, the G of T at the end of the day is going to be this guy. Now, when you are done doing this is what we're going to get at the end of the day. But I'm going to give you a clue, okay? Now, this is for the T. For F, when you are done with this guy, you're actually going to this is what you're going to derive for this. This is F distribution. This is T distribution. Now, I'll show you how I'm going to give you a clue to deriving this.